Database indexing is one of the way to optimize your SQL queries. So today we will be talking about that how indexing internally works and optimize your SQL queries, right? But in case you are not aware of indexing, let's talk about that first, okay? So if you want, we keep meeting again and again with this kind of interesting topics. Make sure you follow concepts of CS. Let's say we have a users table, okay? And we want to fetch the data from the users table based on a name column, right? Let's say if any one rows having named this, we want to fetch that particular record, right? For that, you will be writing a select statement like this, right? Which will give you the result. What this query does, it scans all the records or rows of the database and then gives you the result, right? Now, if your data set is huge or your DB has millions of records, in that scenario, this particular SQL query becomes slow, right? Or it will take a lot of time to give you the result because behind the scene, it is scanning all the records, all the rows present in the table, right? But indexing is one of the way with the help of which you can optimize your query or make your query run a bit faster, right? So this is the syntax to create index on a particular column. So here we are creating index on name column. Okay, as soon as you create index on the name column, what you will notice that your query execution time drop drastically, okay, and your response time is so good. Now let's talk about how indexing works internally, right? When you create index on name column, what happens? A binary tree is created behind the scene, okay? So first of all, database sort all the values present in the name column, and this is how the binary tree is created and your data gets distributed in the format of parent node and child node. Additionally, all the nodes in the binary tree holds the references of its own rows, right? Which actually makes the searching efficient. So let's say if you are looking for record Neha, based on the root node, it is identified that Neha will always exist in the right side of the tree. Here, left portion of the tree is completely discarded. In this scenario, all the records present in the table won't get scanned, right? So without indexing, select statement का time complexity होता है O of n, where post indexing the time complexity will reach to log n. Also, indexing के कुछ ड्रॉबैक्स भी हैं, वो मैं तुम पे छोड़ता हूँ. Let me know in the comment section. And आज के लिए इतना ही. मिलते हैं अगले वीडियो में with another interesting topic. Bye bye.